And good evening, Stooky. My name is Obi-Wan Pez. This is Simplex Pachinko. Sorry about the delay there. Just had a little something we had to fix downstairs. So, thank you very much for the follow. Le Nuit 34. Or let me know what you actually want to be called. And Matthew as well. Alright. Anybody who is interested in math tonight, we're going to be doing all sorts of stuff. So, if you would like to, I guess, form an orderly queue, we can do that at Penn Center's Discord. If you go into that Discord, that is sort of our central repository for all of the math streamers, affectionately known as the Math Chads. So we have here Don Does Math, Zach at e to the 2i pi, Penn Center, Ian Stooky, who is in chat tonight, Obi, that's me, at Nsimplex Pachinko, Danny Highway, and Dr. Gold at Actual Education. So if you have any questions, you can come to any one of us, and we'll all very happily try and help you out, understand the best way that we can. It is important in our experience to get as many different perspectives as possible to try and really understand a subject as deeply as you can. This is, generally speaking, not going to be a place for us to give answers for homework, so much as like work with you to try and get you to properly understand something. And the location you would generally post those in is going to be the Maths Forum. You can also do Maths Chat, I suppose, but Maths Forum is our, again, central repository for it. How are we doing with the music? I changed audio levels, and now I can't tell. Like, it sounds kind of loud to me, but it's only at half. I think it's pretty good. All right. Well, there's the beat drop there, so that's about as loud as it's probably going to get. Generally speaking, I don't want to fight over it, so. Alright. There's a minus 17, so that probably will do it. I'll also turn it down on just my end. Okay. Alright, so... I think tonight we're going to start with our Jacob's geometry book, Seeing, Doing, and Understanding. Matthew, had to make a new fake phone number. Oh, I'm sorry. Oh, that's interesting. Yeah, and you can ask them in chat if it's, like, simple. But generally speaking, people will have more involved questions. We probably want those to go over through Discord. And it's not even my Discord, so... Alright. Christmas mix. Get out of here. It's not time yet. Respect the turkey. So... Yeah, generally we go for something like somewhat jazzy because, you know, we're just making stuff up over here, so. All right. So there's this idea of a work triangle that Jacobs decides that he wants to introduce, and he's saying that the work triangle that goes between the sink, the stove, and the refrigerator in a kitchen should have a perimeter that's somewhere between 6.5 and 7 meters, in that you don't want to have like a very small amount of space such that you're going to knock into things or you don't have room to turn comfortably. And also you're not taking like 4 steps to get somewhere. Maybe it is. No. You make like a few steps to go around the whole triangle. So this is out of Harold Jacobs' book, Geometry. Harold Jacobs was, I'm pretty sure he's retired now, a math educator and math education specialist, and he wrote this particular book to be a little bit different than a lot of the other books that you might see in like a middle to high school setting. He put in a bunch of cartoony type figures. in addition to your standard just regular pictures, he also had licensed a whole bunch of like actual photographs. In this case, some sort of painting, stencil, something, I don't know. Point there. That made it worse. Anyway, yeah, he was trying to get people's interest peaked. So anyway, the work triangle in the kitchen should have a perimeter between 6.5 and 7 meters. Sink to stove. Should be between 1.2 and 1.8 meters. And we're going to suppose perimeter is 7 meters, and sink to stove is 1.5 meters. So 1. What is the sum? Now keep in mind, right, this is like middle school, so... If X is going to represent the sink to refrigerator side, sink to refrigerator side, or the length of, right, the stove refrigerator. Side length in terms of X. Alrighty, so woohoo! Right, so if we know that our A plus B plus C is going to be equal to 7. Right, we could define what they are, but it doesn't much matter. Then, without loss of generality, we can just call A our given 1.5. So 5.5 meters. I'll do what I like. Right, so B plus C can be equal to 7 minus X. That's not the end of it, sorry. Oh, that's not that one. That's the other one. Shoo. Alright, now just, again, arbitrarily pick C or B to be the stove to refrigerator, and so X is then the sink to refrigerator, which I picked C to be the sink to refrigerator and B to be stove to refrigerator. Yes, essentially. Because you can have multiple different circumstances in which you have valid expressions. So we're going to say that our B, the stove to refrigerator side, Hey, Silver. Oh no, it's sensation. Alright, fair enough. Gotta move all the books that are on top of the weights first. Alright, where are the 20s? Make sure you lift with your back. Right, Matthew. So it does stand for a particular quantity, whatever you want it to be. It's just a placeholder, basically. So. I actually never watched Sliders, believe it or not. It's like the one science fiction show I didn't watch. Alright, and then switch down to 15s for endurance. Suck in that gut. That's probably good for now. Oh, good. I just noticed my admin thing over there on the side says unknown user was blocked, so that means that they were banned by Twitch, account deleted, all that good stuff, because it was just a spam account. Woo. Yeah, pretty good deal for me too. My arms have always been like really, really tiny, so it's good that, you know, in my advanced age, we're starting to get some actual arm strength. AoE 2 on hard. I went back and I played it the other month, something like that, and I was having a hard enough time even just beating it on, like, normal. Okay, so we're gonna do sink to stove was 1.5, and we said that the sink to refrigerator is going to be X. Alright, so that leaves B down here. Okay, cool. So that's the picture we can get based on all this information. If X represents the length of the sink to refrigerator, that one. Write the stove to refrigerator B in terms of the other two sides. We already got that. Okay, so then Star Wars Galactic Battlegrounds, which uses the same engine. Yeah. I actually liked AoE 3 when it came out. I was one of the few people that actually did. Then I played it like for about 5 hours, and I was just like, I've got too much work to do. And then I just left it, and it got sunk into a box somewhere. It happens. Sorry. Alright, number 3, actually, draw the work triangle, so I got that. And write the 3 expressions for the lengths on its sides, right? So we got that. Right, and solve the 3 inequalities. Right, okay. So starting from the beginning, we had okay, so sink to stove should be, sink to stove is 1.5, which is not particularly helpful at the moment, but whatever, it's fine. That's A. A should be between 1.2 and 1.8. Okay. Perimeter. Needs to be between 7 and 6.5. Yeah. Empire Earth. Nice. Yeah. I got into StarCraft for about 2 minutes at the University of Tennessee. I was there for a National Order of the Arrow conference, and they had like a whole bunch of dorm computers that were in like the dorm computer lab. And yeah, there was like a dorm computer lab. That's pretty cool. That was like all of them were outfitted with StarCraft 2, I think it was. I guess when did they come out, right? That's the next question. StarCraft 2 came out in 1998. Okay, yeah. Yeah, so we were sitting in the computer lab, me and a couple of friends that I'd met like that week. We were trying to get the hang of like just playing StarCraft because we had all done AoE, AoE2, and like a few other games, RTS wise, and then like there were a whole bunch of players who were from South Korea who were there for college, and like they were absolutely destroying everybody. I'm like, what is going on here? Like, and they're like, oh yeah, these guys, like, they're professional players, and they can do all the, like, you know, the micro managing and micro I forget what the thing was. It was like you macro literally everything. And so, like, you know, a single keystroke just does 5 different things all at once, and it just like creates as many macros as you want. And they're like, oh yeah, these guys, they program macros like all day, and then they come out and completely destroy anybody. I was just like, that is absolutely far too much work for me. So I guess I'll never get good at this game. Alright, so we can also alter this one. So it would be 6.5 less than or equal to our A. Right, well, our A was 1.5, but always, huh? I mean, they do. Haven't you ever heard of Daewoo? LG? But it's also hard to think about the future when you've been told pretty much all your life that your neighbor is just going to send nuclear arsenal at you. So gets a little distracted. I mean, for some people, Matthew, yeah. But other people, it's like, well, what's the point? We're just gonna die in like 2 days, so I don't have to prepare for the next 10 years of my life. Just ask the evangelicals. Right? Jesus is coming in the next, like, you know, imminently. I've been saying this for 2,000 years, but he's coming imminently. This time, it's the right time. Right, so this one's A, this one's B, this one's C. Okay, so okay. So Jacobs is also saying if we use this, we also want to then be able to write the inequalities that happen due to the triangle inequality theorem. So this is going to, I want a different color for the answers. Grab these. Turn color. Cool. Did I forget something? That was a bit fuzzy. How do you mean? Oh. Right, so the triangle inequality theorem says that the sum of any two sides is going to be less than or equal to the third side. So we should get a plus b is less than or equal to c, a plus c is less than or equal to b, and also b plus c is less than or equal to a. Yeah, not even. It's not even the angles adding up to 180. So the triangle inequality theorem is just saying that what we're doing is we're taking the sum of two of the sides has to be larger than the other one. All right, this isn't a super easy one to remember, like that it works that way. Right, yeah. Due to the fact that if you were to draw, right, a rough triangle here, just by looking at it, right, if you want to go from point A to point B, let's not do A like that, point alpha to point beta, shortest distance is going to be along alpha beta. Right? If we introduce delta up here, then what we're saying is that the distance alpha delta plus delta beta must be longer. As it is not a straight line. Between 2 points. Right, because famously, the straight line between those 2 points must be the shortest. So, if we're going to add two different distances, alpha delta and delta beta, then by definition, as long as delta is not along alpha beta, then it must, by definition, be longer. If we want to say that delta can be on alpha beta, then it could be equal to, and so that's where we get this less than or equal to on all these. Oh, greater. Jeez. They're all backwards. It's fine. Right, the sum of two sides must be greater than the third, or equal to. So really, I suppose we could say that the sum of the two separate sides must not be shorter. Right? It could be longer or it could be equal. So by changing the wording a little bit, we can encompass more truthful of reality, more truthful reflection of reality. Yeah, they are a line if alpha beta is equal to the sum of the others, alpha delta and delta beta. Yeah. So yes, but they're using a essentially one-dimensional triangle. If they all fall in the same line, then sure, we're just going to be like, all right, cool. So we usually just say that it could be greater than or it could be equal to, because it could fall on the same line if we're just thinking about 3 points that are in the plane. So it's not, it's not specifically thinking about it must be a triangle. It's thinking about what is the structure of these 3 points. Yeah, matter of definitions. Yep. Alright, so that's our triangle inequality theorem. Which from earlier, we could then say this is going to be a plus b is greater than or equal to c. From earlier, c was x, so a plus b is greater than or equal to x. We could also have a just be 1.5. We could also try to alter a couple of the other things. Yeah, you want to substitute with the theorem. This is not what Jacobs had intended, but like, what are some other ones we could create, right? you could say, hey, I've got almost that inequality right here in the first place. So if we wanted to, we could get the lower inequality by saying, let's subtract x from all three sides. And interestingly, right, this is going to create a slightly different version. So this would be 6.5 minus x is less than or equal to a plus b is less than or equal to 7 minus x. And also, that relationship exists here as well. So here we would say, okay, a plus b has to be greater than or equal to 6.5 minus x. So like I said, not really the intended thing that Jacobs was going for, but you could also create a compound inequality here with these two statements. Alright, and in theory, right, these would have to be equal to each other. Because this is the lowest possible, yeah. They must be greater than or equal to this value, x, and this value, 6.5 minus x. So this does mean that 6.5 minus x and x must be the same thing. So that means that 2x must be equal to 6.5, and therefore x is going to be equal to 3.25. Now, check me in case I'm just completely wrong here, but given the information that we had above, right, that seems to follow that it would have to be this particular way. Now, in theory, so yes-ish, I think in theory, right, it is possible that x and 6.5 minus x could be different values, but like, given the information that we had, we said that our perimeter needs to be between 6.5 and 7. We also said that our a plus b has to be greater than c itself. So, again, are we making a lot, like, too large of a logical assumption that x and 6.5 minus x have to be the same least value? Like, I think that should be fine. I know Stooky knows more real analysis than I do, but right, so in theory it could very well be something like, well, a plus b is greater than or equal to 0 and a plus b is greater than or equal to 2. if they end up, one encompasses the other rather than them being equal to each other, right? Then one would override the other rather than them necessarily being equal to each other. So rather than this being the only option, this feels like it's kind of like option 1, where these end up being the same thing. But then you should, in theory, have 2 more options where one is bigger than the other and then switch. So like if x were greater than 6.5 minus x, and if x were less than 6.5 minus x. It's all solving for the same stuff. It's just going to be greater than or equal to, or greater than or less than 3.5. So it's the same numbers, right? It's just like, do we need to take those into consideration? In which case, do we have any real information? Yeah. I mean, I get the feeling that it's just trying to build a bridge too far here. That x could be any of these side lengths and it's fine. Right, provided that both of these things hold. And in theory, x could be any particular positive value. That still makes this all work. Another thing that we could do is subtract a from all 3 sides. So that would bump our low side down by 1.2, bump our high side down by 1.8, and then get rid of a in the middle. So that's also another inequality that we can create from those 2 separate inequalities. So if we subtract that, that's going to be 5.3. It's less than or equal to, no, hang on. Hang on. You got mugged by 6 dwarves last night, not happy. Yeah. Obviously he wasn't there. That would make it 5.2, which would be very awkward. So, obviously that's not going to work. Alright. If a is less than, right, because what's going to happen? Okay, so this is an interesting thing, right? We can't just subtract an inequality directly. So if we take 1.2 less than or equal to a less than or equal to 1.8, and we want to negate all of these things and make it negative a, then this is going to be greater than or equal to 1.8, but that's really ugly. So we're going to flip it to the other side and make it less than or equal to, negative 1.8 is less than or equal to negative a is less than or equal to negative 1.2. Right, so normally you'd have to think about this in terms of each of the individual inequalities are flipping. I don't really like to think of it necessarily as flipping unless we're doing this graphically, right? This was like 1.2 and 1.8. We've got something that starts here, ends there, and it could be any value in between. This is a. If we want negative a, then we have to take this number line and flip it. And go from negative 1.8 here to negative 1.2 here and cover everything in between. Unseenable. Good evening. Absolutely. Superposition. So the principle of superposition is saying that we have, if we have any number of solutions to the differential equation, homogeneous solution, then we're going to be able to say that any linear combination of those things is also a solution. So if you were to go in and say, all right, a constant times the first one, plus a constant times the second one, plus a constant times the third one, etc., as far as you need to go, right, as many solutions as there are, you could do that. Or you could think of it as, like, you know, just the first one, just the second one, just the third one, individually. Yeah, never gonna viv you up. Good evening and welcome back. I have been working with inequalities and graphical representations for quite a while. And I invented, actually, a method of solving absolute inequalities that works out pretty nicely, which some of my students have really run with and tried to tried to break it. It was quite amusing. One of my colleagues also was like, well, I'm not sure that actually works. So he tried, like, messing around. Eventually he got it to break if... yeah, I mean, it's like, if it's not linear. I was like, well, yeah, but we're going to have problems if it's not linear in the first place. If it had expressions on either side, then it can cause problems as well, because it's going to have to check, like, on which side the inequalities are, by looking at the by looking at the multiplicities of all the zeros of this thing, or when they intersect. What are the multiplicities of the intersection points? It does all sorts of weird stuff. Yeah, so if you just had, like, less than or equal to x minus 3, I should have been more specific, I guess. So if it has a variable expression on either side of the inequality, then it can potentially break. But again, it all comes down to, like, multiplicities of the solutions to the regular equations when you create them. Okay, now if we add this to both sides, that should fix it. So we get our 6.5 minus 1.8 is going to be a 4.7 less than or equal to negative a plus a is going to knock that out, so you just get b plus c. Less than or equal to negative 1.2 plus 7 is going to be a 5.8. Okay, so this also creates a second inequality. If we wanted to, we could then input x for c and then subtract that off from both sides, and then get a value for b, which is going to be 4.7 minus x, less than or equal to b at... No, that's fine. Less than or equal to b, less than or equal to 5.8 minus x. So you end up with the same stuff. You just have to know what the value for x is going to be. Oh yeah, I mean, you're going to run out of combinations eventually, but... Let me rephrase that. You're going to run out of interesting combinations eventually. You can always subtract 1 from all, you know, pieces, and then subtract 1 again, and subtract 1 again. It's trivial. Calculate the number of combinations, yeah. Probably has some sort of choose variable we can throw in there. There's that b plus c, 7 minus a. Yeah, we already got rid of the a, so that's fine. B plus c. Yeah, we don't have really anything else there. Okay. Ads are coming in about a minute, so everybody go and find yourself a drink, cycle your water, stand up, stretch, fight, 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 walk it around, do whatever you need to. Gotta keep limber when you're doing these mathy things. I will see you back here in 3 minutes. And then we'll get on with some of this other stuff here. If anybody has any other questions, let me know. And Viv, was it? Oh no, Unseenable. I can write out the superposition thing if you're interested in that. So, 3 minutes, like I said. Be right back. Alrighty, let's see if I can remember anything from last week. So, let's see, we were doing some Escrima this past week where we were taking our sticks and we were doing so they're called sticks to heaven. I don't understand quite what that is, but you're probably sending the other person away from this world if you're doing this. Keep in mind, these are supposed to be machetes. So we're holding it over here. We go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so after doing the standard sticks to heaven moves, what we were doing was we were coming from shoulders, and we were trying to swing, cut down, down, up, up, back to shoulder, down, down, up, up, back to shoulder. Keep swapping. This is mostly just warm-up. And then we were doing down, down, and now we're in left hand sticks to heaven. And then instead of doing it again on this side, we come from the low side and swoop up, up. This is where I keep getting lost. Because now we're cutting... Oh, it was just up, up, put on shoulder. Yeah. So down, down, we're in a sheath. Sticks to heaven. Swoop up and up, back to shoulder. Right, and then we have to do it on the other side, because otherwise you're uneven. So down, down on the left. And swoop this way, and up, up. So the our teacher that we have here, the instructor, is like he's a pretty good guy, but yeah, he's really good at several martial arts, and Escrima is like the one that he's technically still learning, but he's a good teacher nonetheless. So these are called Amara, and they like do all sorts of different things in order to get into different positions, in order to get into like all the different motions, and it's really cool how to work with it. Let's see, we come from shoulders. I think we did swat, swat, and then swoop down, and now we're back here. So now we can go into here, and then that's still a right side though. Huh. I want to go that way first. So how do I get there from here without hitting myself? I don't think that's going to happen. So I think we'd have to go like out and then back, which is really awkward. A lot of this stuff, as with most martial arts, ends up becoming make the thing your own. So eventually you're going to figure it out for yourself and like do some cool stuff. I'm still a first-degree brown belt in Tangsudo Karate. However, technically, I probably could have gotten a black belt. It's just that I never got a sponsor for it, and I've never quite been good enough. So there's all sorts of... I've got all sorts of fun problems. No, I'm alright. I think motivation was always my problem, and then confidence. I was never really confident in doing it. And then we also did sparring with hands. We did the same motion. So we were You know, coming from here, we were also doing our, what was it? Come across, right, come across, and then down. This is weird because you don't have sticks. So I was like, do 1, 2, 3, 4, 5. Oh yeah, we actually did do it from here, so we kept our lower hand down so you couldn't actually see what was happening with it, and that could be like a, you know, slight surprise attack coming from the hip. But 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then every time we're doing this, we're also striking against our opponent's arms. And so, like, our training partners, we're constantly beating our, which one's that? Ulna? Constantly beating our ulnae together, like, the entire time. And I'm just like, this is not comfortable. So I went away. This is like the first time that I came home with actual bruises, because all the rest of the times when we were playing, you know, we're striking at each other with sticks, but we have sticks to defend ourselves. So you're not really, almost ever, hitting someone else's body with sticks. Hey, Punching. Yep, absolutely. Yeah, Matthew, it is definitely to get the blood flowing. It helps with cognitive abilities as well, because, you know, you're keeping your mind off of stuff for a minute, and, like, your brain's still working on things in the background, so if you get confused about things, you can go do some athletic activity, and, like, the brain is, or your blood is reaching all the different parts of your brain and flowing really well and getting oxygen in there. Exercise after you eat, yeah, I mean, that works too, especially getting all of the snacks 6 times a day. Yeah, well, you're getting all of the blood working into your digestive system to get moving. It works really well. That's also why a lot of the, like, Romans and Greeks love to have constitutionals, so they would go on walks. Sometimes not particularly brisk walks, but, you know, at least at a reasonable clip in order to get the blood moving. So it's all sorts of good stuff. Yeah. Yeah, Matthew. I've definitely neglected some, particularly my arms, which, again, thank you, Sensation, for making me lift weights for a bit. Typically during my day, I will go cycle. And, I mean, literally cycle, not just cycle muscle groups. I will go cycle, you know, bicycle riding, about 5 miles each way. So, get a good 10-mile out and back, usually. Allegedly, I can now also go to Ripley, which is about 5 miles, and then go to the next town over. Oh, definitely more than most people, but but, like, I look around town here, and, like, everybody owns a bicycle and everybody uses it on a weekly basis. It's just like, oh, okay. And I mean, not literally everybody, but it just feels like almost everybody. Oh, hey. I also found something really cool in the Elite Dangerous stuff that I was working on. Obviously, we're not going to be doing that today, but so I've been working on this stellar cartography project with Super Chicken, who's one of the other Elite Dangerous streamers, and I was like, all right, so what are you looking for? And he told me, the criteria of the stuff that he was looking for. And I was like, okay, that's kind of cool. And he had a like big spreadsheet, and this last week he was like, okay, so modification, this is what I'm looking for. And when he told me that, I added 2 extra columns and started, like, rather than visiting all the systems, because that's going to take friggin' forever, I can actually just go into, like, the map form, and every place that I've already visited, that map is available to me. So I was just like, oh, well, I can just go in there, and even some of the ones that I've never been to, I can actually just click on it, and it shows me the system, and I'm like, oh, that's really nice. So I just updated a whole bunch of, like, does this have the criteria that he's looking for, this extra criterion that he's looking for, and I found 3 candidate systems in one day. So, you know, weeding out from a list of, like, I went through the first 200, and there were probably 50 systems that were, like, borderline, but when I added this new criterion, we're down to 3, and one of them is actually good, and the other 2 are like, maybe. So we have 1 realistic candidate system out of those 200, and granted, it's a little close. We were thinking, like, the generation ships that were launched out from Earth would need a certain amount of time to get somewhere, so it should be about, like, 70 some odd light years out, away from Earth. And right now, the candidate system I found was like 30. The first 2 are about 29, and the third is like 31. So the really good one is like 31. And then I have another scan. I have 2,000 systems to get through total. Yeah, you can't use chainsaws on NPCs in Satisfactory. So disappointing. Yeah, so our community in Maryland was pretty decent with biking, so you could go off on trails in the backwoods and rarely ever have to actually be on a road. It was pretty nice. In many other places in America, absolutely, people will dangerously get close to you, if not literally clip you on purpose, because they just hate bicyclists, I guess. I don't know. Yeah, not where we were, because they're pretty strict about, like, biking laws and safety and things like that. But some other places I've heard of people getting clipped or intentionally pushed. Or intentionally run off the road, so they'll, somebody will just drift in front of you. Virginia, yeah. Yeah, so our family moved to the UK, just a reminder. And yeah, definitely bicycling is way nicer. DMV area, oh my goodness, yes. Anybody who is uninitiated, that is the Delmarva Peninsula. So, especially the eastern shore of Maryland, the little chunk of Virginia that goes like that, and the Delaware, especially southern Delaware. Yes. Unseenable, absolutely. So we were talking earlier, right? So if we have solutions to differential equations, which end up being like p of x y double prime plus q of x y prime plus r of x y is equal to, you said homogeneous, so equal to 0. Our solutions here are going to be y1 and y2. We know that there are going to be two linearly independent solutions because this is a second order differential equation. That is that easy. You can know that you will get two answers for a second degree differential equation. No, second order differential equation. It's very much the same as the degree of the polynomial, because those of you who were around during my differential equations classes remember that we'd said, okay, we're going to assume that y is of the form e to the rt, or what we ended up doing was skipping right to the chase and saying, okay, this is e to the lambda t, because lambda is literally the eigenvalues that we're going to get for this. Y prime is then going to be lambda e to the lambda t, and y double prime, sorry, x. Habits. Can't mix variables. Lambda squared e to the lambda x. So when we plug all this stuff in, we end up getting this p of x times lambda squared e to the lambda x plus q of x lambda e to the lambda x plus r of x e to the lambda x equals 0. E to the lambda x will never be equal to 0, so therefore all of this must be. And, sorry, typically, when we do this sort of thing, p, q, and r are just going to be constants. But that's less important at this exact moment in time. What is important is that we're saying, okay, our solutions are just going to be y1 and y2. That means that if we plug in y1, right, p of x times y1 double prime plus q of x y1 prime plus r of x y1, we will end up getting this equals 0. Has to work. It's what the definition is, right? You plug this in, you'll end up getting a true statement. And similarly, if we do p of x times y2 double prime plus q of x y2 prime plus r of x y2, we're also going to get this equal to 0, again, by definition, because it is a solution. Laundry just went off. And it just got back. So this is also going to allow us to say the principle of superposition is going to say that p of x times c1 y1 plus c2 y2 double prime plus q of x c1 y1 plus c2 y2 prime plus r of x times c1 y1 plus c2 y2 is equal to 0. So this is what the principle of superposition says. It is a theorem, and it is super easy to solve to make, or to show that this in fact does work. How do we know? Because derivatives are linear operators. Meaning, if we have a derivative of some constant times y, that's going to be the same as the constant times the derivative of y. Here I'm just using a generic derivative, capital D. Right, so principle 1 of linear operators is that if there's a constant on the inside, it could just be shoved out to the outside. This is the same as limits. This is the same as literally linear functions. Right, there's a lot of other stuff you can use it with. And then the second principle of derivatives, or the second principle of linear operations, is that if we have the derivative of y1 plus y2, right, two separate things that are being added inside of the linear operator, then that's the same as taking them separately and then summing them. So because that's true, we could actually just take all of our... you could go either way with this. So typically you're going to prove it from the principle of superposition part that I wrote below, and then multiplying it out, like taking the derivatives of stuff and then multiplying everything out. Mm-hmm. Okay. Right, so let's do it this way. We find something up here. We say, okay, what's this going to be? So 6 lambda squared e to the lambda t plus 5, it's not y, lambda e to the lambda t plus, minus e to the lambda t equals 0. Pull out e to the lambda t, multiply by 6 lambda squared plus 5 lambda minus 1. Again, this stuff has to be 0 because this can't be. So now we have a characteristic equation, which is 6 lambda squared plus 5 lambda minus 1 is equal to 0. This one is nice and easy. This will split into 6 lambda minus lambda. Right, so here we get 6 lambda, left with lambda plus 1. Here we get a minus 1, we're left with lambda plus 1. Six lambda minus 1 times lambda plus 1 is equal to 0, so lambda is going to be either negative 1 or positive 1/6. Okay, so then we go back up to the top and we say, okay, this is going to say that y1 is going to be e to the negative 1t, and y2 is going to be e to the positive 1/6 t. Right, so the characteristic solution is going to be these two things. Also could be called the solution basis, but that's also a linear algebra term, so I don't want to like hijack it. It may also not be 100% used in the exact same way, so therefore, right? Right, and then we say that, okay, this also means that, again, C1 y1 plus C2 y2 is going to be our homogeneous solution, YH, which is C1 e to the negative t plus C2 e to the 1/6 t. Right, so they're just giving you the first and second solutions, and then you have to figure out what the values are going to be. So, let's pretend that we did that. Right, so they give you these two right here, y1, y2. These are the separate things. And then they also give you initial values. So, we'll go with something like that. Right, then we'll also go with y of 0 is 2, and y prime at 0 is negative 3, because why not, right? So what that's going to do now is it's going to say, okay, let's take those initial conditions and our homogeneous solution, and now we can find the specific solution that we can then use the initial conditions for in order to find which one of these many different possible solutions we're going to highlight. So essentially, what you've got here is, again, y equals C1 e to the negative t plus c2 e to the 1/6 t. Alright, so then we put in sliders for c1 and c2. When c1 and c2 have these particular values, 1 each, then we end up with a solution that looks like this. Zoom out a little bit. Right? It's an exponential on the left, it is decaying, and then when it decays to very, very small amounts, then our exponential growth takes over on the right. It is a bit slower, but nonetheless, it then takes over and continues from there. These are not asymptotic. This is not a quartic function, even though it looks like it. This is two exponential functions that are behaving in slightly different ways. If our C1 is more important, we're increasing that value, then it extends the height of those values on the left, and if we make it negative, it'll actually eventually, well, once we make it negative, it'll flip it over and go the other way. Alright, and then if we move C2, it's going to again move the right-hand side either into the positive or negative region, and again multiply by a certain amount. So, which one of those is going to be the correct one to use? Well, that's when we go over to our initial values, plug them in, and we end up getting that when y of 0 is equal to 2, that corresponds with, on the other side, c1 times e to the 0 plus c2 times e to the 0. So c1 plus c2 is 2. Easy enough. Then y prime of 0 is going to be equal to negative 3. Well, this is a bit different. We're going to take this is going to be c1. The derivative of e to the negative t is negative e to the negative t plus c2 e to the 1/6 t. Derivative of e to the 1/6 t is 1/6 times e to the negative e to the 1/6 t. Right, so that 1/6 just comes down there, and then what we've got now is negative 3 is equal to negative. See, oh, sorry, those are supposed to be zeros. Is a negative c1 plus 1/6 c2 is going to get us a value of negative 3. Okay, and now we're just back to an algebra 1 problem. Maybe algebra 2. Right, this is just a system of equations. And then we can also use linear algebra to solve this. This one is not so bad because you just need to add your C1s together, and we get a 0 there. We also get then a negative 1 on the left, and a 7/6 C2 on the right. So C2, yep, no problem, is negative 6/7. And then C1 must be 2 and positive 6/7. Alright, because C2 is going to be a negative value. So add it to both sides. 2 and 6/7 is going to be 20/7. So, if C2 is negative 6/7 and C1 is 20/7, that is the one answer we want, or the one answer we're going to get for it. This is the single particular solution within this larger general solution, the family of solutions. Who's next? What is an operation, though? So we represent them by a symbol, but it is a class. So an operation is going to be a class that relates some set of things in some way. I am being intentionally vague because it can literally be anything, right? It could be that we have an operator star. This is not multiplication, right? This is just some operator. Now, it is possible that we could feed one thing into the operator. So, for example, like 3 star ends up being 9. 4 star is equal to 16. Right? You know what this is. Right? Or we could do something like 5 star 6 is equal to, yeah, it could be all sorts of stuff. Let's see, I want to do something interesting. 5 star 6 could be, let's go with 18. 3 star 8 would be by these rules, because I'm actually doing something with actual rules here. Negative 12. Alright, 4 star 1 is 41. Right? So the more information I give you, the more you're going to be able to figure out what it is that this thing is doing. Might take a while. In some cases, it might be impossible for you to actually decipher what it's doing. That would be considered a hash function, where you're just like, your inputs, even if you know what the inputs are, the outputs are nearly indecipherable in terms of, or nearly unpredictable. Eventually, again, if you feed it enough data, you're going to figure it out. But there could be some where it is an intractable problem, where it would be unlikely for you or even a computer to just kind of come up with the right format. Right? Or we could end up doing like 7 star 4 negative 2. Right? We could make up notation. We could do all sorts of stuff. So, generally speaking, you're probably going to end up with a unary operator like this. Binary operator. Right, unary operator is just taking one thing in, and again, in this case, it's just square it. In this case, it was 12a minus 7b is what a star b was. So they also fall into different classifications, right? So unary and binary are just how many inputs do you have, and then what is it doing with it. But we also have the linear. Right, in the previous example, we saw linear operators. So a linear operator, again, has that quality where if you have a constant on the inside, then that constant is directly just factorable, essentially, on the outside. What category does operation fall under? I mean, so in computer science, it's more like a function. Unary operators are also mathematical functions, usually. I can't think of one immediately that just doesn't work. No, I mean, you could create something that's not, literally just not a function. But if you're doing computer programming, that's going to be really hard to actually, like, have a computer science function that is not also a mathematical function. Unless you start invoking stuff like rand, right? Some other types of computer science functions, which are not literally functions, because if you plug in different, well, if you plug in the same input, you don't get the same output, right? So rand, I just want a random number. Give me a random number. The computer on the back end is going to also take possibly the date, the time, the last keystroke entered, and throw it into a hash algorithm to come up with a pseudo-random value. It's possible. Most of the time it's just kind of a lookup table. Where it's like, I don't know, pseudo-random, go. So, like, overall, the random number generator could very well be a pseudo-random number generator could be a mathematical function in that the inputs are never quite the same, so the outputs are going to end up being different, and that's fine. Even if the user inputs the exact same stuff every single time, the function itself is going to be a mathematical function because the inputs technically are not the same, even if the user inputs the same things. Right, this is not like a square root function inputting both a positive and a negative value, right? This is saying that the user is going to input some sort of seed in order to get a random number, and then also the computer is going to use multiple different inputs in order to get the result. So, yeah, no problem. Yeah, it's really fun to talk about. I was doing computer science. Well, okay. I did a little tiny bit of computer science in a class called Neural Networks, and my spouse and I were both in that class. It was cross-listed between her computer science degree and my math degree, so it was really cool, and the both of us got to take it at the same time, and had a lot of really cool discussions and coding sessions at home. Woo! All right, but have a good night, Matthew. I mean, that's the question, right? So if you want to talk about it mathematically, then it can be a physical process. If you're talking about it philosophically, then you're going to have to define it. And then can that answer slip back into mathematical? Under the mathematical purview. Yeah, it is quite possible that I'm not qualified to answer that question. Yep. So yeah, I'd recommend Zach. Or Stookie if they're here. Right, who else? What else do we want to talk about? We've still got this other stuff over here from... Never technically finished this one, so you know. Alright, A plus C is greater than or equal to B. In Calc 2. So it definitely matters, like, the kind of problem you're looking at. And if you're trying to go for like a particular method. Yeah, I mean, they all take a little bit of time. That's an interesting one. That's not what I wanted to undo. Come on now. No. While you're getting that one on. So here, I'm actually kind of interested in doing something completely alternative, which is that I'm seeing vertical angles here and here, which means that we're going to have one particular obtuse value for APC here. Which has to be the same as AQC, I think, because again, now we've got 3 of the same. That's not the same. Never mind. Well, okay, literally just 1/2 C. Why would I do that? Okay. Which is equal to measure angle AQC. Okay, you're going up. You already posted it, right? Grabbing the wrong mouse. That's terrible. Pushing, I see your rotation of solids. Well, I don't see any other questions. Oh, there we go. Apparently I just needed to actually get out and back in. Okay. Evaluate proper integral or state that it is divergent. So, it's not 1/2 x. Man. 1/2 c. Evaluate improper integral or state that it is divergent. Sure. So like the biggest problem that you're going to run into is this thing right here. So what can you do with it? Mm-hmm. Okay, I don't know where the division comes from. So, what we've got here now, though, is that these are separate integrals from 8 to infinity of 1 over x minus 7 dx and 8 to infinity of 1 over x minus 6 dx. Alright, so you take your 1 and negative 1, plug it back into a and b here, and have that replace this one up here. So, natural log absolute value x minus 7 from 8 to infinity plus natural log, oops, that's a negative, minus. Yep. Oh. Yeah, right. Just adds. Yep. So what I'd always done anyway was you pick, is it your A or is it your B, and then substitute that in appropriately. Sometimes it's both. It's A in one case and B in the other. You know, at negative infinity to infinity, something like that. Yeah. Then satisfy whatever your instructor wants for the, like, how do you know that the ratio of two linear functions is going to be equal to the ratio of their slopes? One of my favorite is probably just saying that we're going to do 1 over b times everything on top and the bottom. So we get 1 minus 7 over b over 1 minus 6 over b. And when b goes to infinity, these two things go to 0. And then we're just left with 1 minus 0, both top and bottom. So it's the ratio of their slopes, 1. Yeah, it just follows along. Hey Zach, how's it going? Alright, I sort of want to take a crack at this just to see. It's quite possible that... I mean, they already solved it in there, so I'm not too worried about like, oh no, they need an answer. But... dissertation stuff? Yep. A little tough? Okay, cool. Come from way over on the side because you can't point at stuff in the middle of your diagram. Alright. 180 minus x here. These are both x's. This is 180 minus a minus x. Half of a. Use trig and failed using law of sines. Oh no. What's the goal? AC. Alright. So there's two triangles that one's a part of. Which also means that the other side of this is going to be a plus 1/2 C. It's also going to be 1/2 A plus X. This is also 180. Hang on. This one does not have two triangles that it is a part of. This just has the one big one. Oh, no. Right, this small one here and this big one here. Sorry. This small one here and this big one here. So it is also 180 minus 1/2 A and all of C. You just reframe it until some of these things are parallel, right? No, we can't actually do that. So if we subtract 90 minus C, this is going to end up with 180 minus 90 is 90. Minus C is plus C, minus 1/2 C is positive 1/2 C. this one's not going to help. Subtract the 90 minus A from this one, so that's going to end up being 90. Plus 1/2. What if? Everyone's favorite. What if we do the sine of APC divided by its opposite is Z is going to be equal to sine of angle A divided by CP, which is 8 root 2. Z is equal to 8 root 2 So when done from the perspective of APC, this is how we get Z. When done from the perspective, we need AQ. We can do something here with Measure of A, no, it's a QC. I need like a mid C, whatever that's going to be. 180 minus X, I got that. Okay, well, we can do this from the perspective of AQC. That'll work. Sine of AQC divided by Z, the opposite. It's going to be equal to... And then here we want C, sine of C entirely. Divided by AQ is 9. Sine angle AQC. Okay, now, a PC is also 90 plus half C. A QC is 90 plus a half A. Oh, plus 1/2 A. Sine 90 is 1. And this is cosine of a half c. Okay. Okay. I'm gonna see if I can work on this a bit. But unless anybody has any other questions, I think we're gonna pass it over probably to Dr. Gold. I saw he was on a little while ago. Keep the math going. Dawn has been up for 3.5 hours. Dr. Gold's only been up for 17 minutes, so that seems the more likely place to go. So, for the rest of this week, might end up doing something tomorrow, depending on how I'm doing. Thursday I usually skip, just because I've got Escrima until 8:40, then it won't be until almost 9:30 that I even get on. Gotta get my tea and everything, you know. So we're probably going to limit ourselves to a game stream tomorrow, if we do it at all. If anybody has any particular questions on math, you can always ask it. It doesn't matter what I'm doing that night. I will always stop and give you at least a quick answer. So. Righto. I hope everybody has a good rest of your week, and we'll be doing on we'll be doing game stuff on Friday, probably Satisfactory again, and then Sunday we've got Spooky Sunday. So, Neolonibus Heal. I definitely believe math can be taught better. So the way in which we are learning it is based off of Peter Liljedahl's Building Thinking Classrooms, which I have found to be really helpful, and I know Zach is at least a fan of reading this to to like get some interesting ideas out of it at the very least. But yeah, I tried doing that in school. It sort of worked, but I had some problems implementing it in one semester. So I have an N of 1 at this point, so like, wasn't that bad. Alrighty. We're gonna head over and see Dr. Gold. I'll see you all in chat over there, and have a good rest of your week. My name is Obi-Wan Pez. This is N Simplex Pachinko. See you next time.